Now, so we've talked about measures of center. Now we're going to talk about measures of variation. All right. Measures of variation. Now, what does variation mean? What's the root word for variation? Vary. What does it mean when something varies? Changes. Now, let's do a hypothetical. Suppose I'm scared of flying. I'm not, but let's just suppose I am. All right, and suppose I've got to fly. So I don't have a choice. I've got to crawl on an airplane, you know, corona or not. Okay. All right, A and B. But I've always been scared of flying. So I go do some research. And I'm trying to figure out, I can go on airplane type A or airplane type B. So I go start looking, and I find out that this one has an average engine problem. You know, there's an average problem on this type of airplane at around 1,200 hours, 1,200 hours. That's your average. So then I go look at an airplane B, and lo and behold, the average trouble occurs around 1,200 hours. So their measures of center are the same. They both have trouble average-wise around 1,200 hours. So they look the same. But being me, which is true, that's not good enough. Like I'm a little OCD, so I gotta go dig deeper. So I go find out that this thing had a really bad problem one time at 1,296 hours. All right, one time there was a serious malfunction at 1,186 hours. One time there was a problem at 1,215. One time there was a problem at 1,172, so forth. Now, I go look over here. I'm so pumped because one time this thing didn't have a problem until 2,316 hours. One time the wing fell off with 25 hours. Okay. One time there was a major malfunction at 1,463. One time there was a serious engine failure at 302. Everybody with me? Now, how did they get 1,200? They took all their data and added them up and divided by how many there were and got 1,200. Same thing over here. They take all their data and add them up and divide by how many there are and get 1,200. Are these planes alike? What if both of them have been flying for about 450 hours? Which one am I going to crawl on, A or B? A. Do you see that this data varies more? All of this data is pretty centrally located around the center. It's much more dense. Everybody with me? This data had spread out a lot further. It varies more widely. So what we're saying is measures of center are important, but sometimes they're not sufficient. Sometimes even things with the same center, the data varies differently. So we're going to talk about how do you measure how the data varies. Now, the first one is going to be your personal favorite. All right. The first way is called range. All right. Range is simply high minus low. That's all it is. So if this was your data, 5, 8, 6, 5, and let's go with 9. What would your range be on that data?
4.
How do we get that? What's our high? 9. What's your low? 5. 4. Go. Now, let me caution you about something. That sounds a lot like something we've talked about. What does range sound close to that you had for homework for today? Mid-range. Now, they're close enough to be dangerous. Sometimes the simplest thing is what you're going to miss on your test because you're not noticing. What two numbers do you use to find mid-range? High and low. What numbers do you use to find range? High and low. But with mid-range, what did you do with the high and the low? You added them. With range, what do you do with them? Subtract them. With mid-range, after you add them, you divide it by what? 2. You divide by anything here. So they're close enough to be dangerous. So you've got to get straight. When do I add and when do I subtract? When do I divide and when do I not? So when you hear mid-range, I'd rather you think midpoint. Because how did you get midpoint? You took two numbers and did what? Added them and what? Divided by 2. So heavy on the mid there, not on the range. Everybody with me? Now, this is the one, though, that you're going to spend the most time doing. Standard deviation. All right, standard deviation. Now, there are two symbols for standard deviation. An S and then a lowercase sigma. Looks like this. Kind of like a zero with a little tag top. Now, you know how in English you have uppercase letters and lowercase letters. It's the same thing in Greek. All right? That's a sigma. It's a capital. That's a lowercase. Okay? Now, an S is the standard deviation of a sample. Sigma is the standard deviation of a population. Okay, standard deviation of a sample and a standard deviation of a population. Which one do you think you're going to see more often this semester? S's or sigmas? S's. Why do we not use populations a lot when we're studying something? We talked about that a little bit. Why do we not use populations a lot?
Hard to get one.
Hard to get them. I mean, usually they're too big. I can't find all of them. I can't afford to sample. I can't afford to talk to all of them. I can't physically have time to do that. So when we're doing studies, more often we use samples than we use populations. We'd love to use populations, but often populations are too big. Okay? So you're going to see S's more than you see sigmas, but you are going to see both. Now, this is not exactly what it is, but it's a way to kind of wrap your head around. It's kind of the average distance of each piece of data from the mean. Now, so in other words, you get a mean for the data. Every piece of data is probably not going to be exactly that middle number. So how far apart is each one of them? It's the average of those distances, sort of. Okay? Now, I'm going to work it different ways. I'm going to work the same problem 3 different ways. All right? On a test, you can work it any of the 3 ways. The 3rd way is going to be your favorite. But I need to do the other 2 so you know what you're doing. Is everybody with me? All right. Let me do this and we'll go over here. Okay. All right. Here's my data. 5, 8, 6, 5, and 9. And it says find the standard deviation. All right, I'm going to make a 3-column table. X, X minus X bar, and X minus X bar squared. Okay? Now, what did I tell you X stands for the whole semester? Your what? Your day. Now, it doesn't have to be in order. I'm just, like I said, a little OCD, so it makes me feel better. You don't have to put yours in order. So 5, 5, 6, 8, and 9. Okay. Now, look what this column says. What's that X bar stand for? Your mean. So what are you supposed to do here? Take every number and subtract the what from it? The mean. And write those answers down here. So what do you have to go find that you don't have yet? Your mean. So you go find your mean, and then take 5 minus that number and write the answer down. Take 6 minus that number and write the answer down. So you fill out that middle column for me. And then we'll double check. What'd you get for your mean? When you added all those up and divided by what are there, 5? What'd y'all get for your mean? 6.6. All right. So then I had to do 5 minus 6 6/10. Okay. What is 5 minus 6 6/10 going to get me?
Negative 1.6.
Negative 1 6/10. Okay. So the same thing down here. 5 minus 6 6/10. 6 minus 6 6/10. 8 minus and so forth. All right. So again, I got a negative 1 6/10. What's 6 minus 6/10? A negative what? 0.6. What's 8 minus 6 6/10? 1 4/10. What's 9 minus 6 6/10? Everybody okay? Now let me ask you this. Why can't I just add these numbers up and divide by 5 and get an average? Why is that not going to work? Why is that going to be misleading? Well, let me ask you this. What if one answer was a negative 4 and the other was a positive 4? What's the average distance of the values? If the distance here is a negative 4 and the distance there is a positive 4, what's the average distance they are? They're how far from the middle? 0. If I add them up and divide by 2, I'd get what? 0. Well, no, this one's not 0 away. It's 4 below. This one's 4 what? Above. Do you see the fact that some of these are negative and some of these are positive or problematic? So if I just add them, they're going to cancel each other a bit. And that's going to be misleading. So I can't do it that way. Now, there are ways the problem could have been solved. And different disciplines do it differently. All right. What's one way that I can get rid of those negatives? What thing in math do you do that turns negatives into positives? That's what they do. They square them. So they're going to go over here and square them. Now, isn't that going to change something though? So if it was 4 away, suddenly that number's going to turn from 4 into 16. Is everybody with me? So if they square them, what are they going to have to do later to fix that problem? Yeah. So what I need you to do is I need you to square all these numbers and write it in that column. All right. What's a negative 1 6/10 times a negative 1 6/10? What'd y'all get?
2.56.
2.56, all right. What happens when you square 6/10, negative 6/10? I get a positive what? 0.36, so 3,600. What happens when you square 1 and 4/10? You get 1 and what, 9,600? What happens when you square the 2 and 4/10? I'm gonna get, what was it, 5 point what? So instead of adding these, I'm gonna add these. All right? So add the squared values. All right? So in symbols, that's what I'm saying. Add up those squared. All right, so when you add this 2.56 twice and then to a 0.36 and a 1.96 and a 5.76, what did y'all get there?
13.2.
13.2, y'all agree? All right, so I got 13.2. All right, so that says the same thing in symbols. You know, it says add up those squared answers. Now, here's what's going to be a little strange. What do you think I'm about to divide by? What number? How do you find the mean? In other words, everybody with me? An average. You add the numbers up and then divide by what? How many you have? 5. So you think I'm going to divide by 5, but I'm not. I'm going to divide by 1 less than that. We'll talk about later kind of why. Okay? So I'm going to take this 13 and 2/10, and I'm not going to divide by n. I'm going to divide by n minus 1. All right? So I'll take that 13 and 2/10 and divide by, you're right, there are 5 numbers. But what's 5 minus 1 going to give me? 4. All right, so get me that answer. Did you get 3 and 3/10? And now I'm going to have one more step. What did we say we were going to have to do? We squared it, so what am I going to end up doing at the end to fix my problem? I have to do what? Square root it. So go get me the square root of this 3 and 3/10. So square it, square root it. To the nearest tenths, you get about 1 point something? 1.8. That is my standard deviation. Now, here's the way they write the formula. All right, that's what you just did in a table. You found the mean, and you took every piece of data and subtracted the mean from it, right? Now think about order of operations. What do you do after parentheses? Don't you do exponents next? So then you took all those answers, and what did you do with them? You squared them. Then what's that symbol say you do with all those answers? It means you what? You add. Isn't that what we did right here? We took these and we added them up. And that's where we got our, what was it, 13 and 2/10? Then, I'm sorry, I messed up. Don't put n times n minus 1, just put n minus 1. All right. So I divided by n minus 1. So 5 minus 1 was indeed what? 4. And then what was my last step to take the what of that? The square root of that. So I end up saying that every number is almost 2 from the middle. Now think about it. What's my middle? Is my middle about 6.6? Now see, this one's about 1 6/10 away. This one's about 1 6/10 away. This one's about 6/10 away. That one's about 1 4/10 away. And that one's about 2 4/10 away. So the average distance is about 1 point what? 8. Everybody with me? Now, that's one formula that's in your book for standard deviation. I just kind of got the numbers to put in a formula from a table. Is everybody with me? So when we added the numbers up, remember, we took everything and subtracted, squared, and added, we got our 13.2. And then 5 minus 1 is indeed what? 4. Everybody with me? And so we ended up with the square root of, when we divided those two things, you told me it was 3 3/10. And then you told me the square root of that was about 1.8. So that's using that formula. Now, in your books, on page 99, they have that formula. Then they have a second formula. All right, and we're going to use the second formula. Because it's got your favorite word next to it. What does it say? What word is next to that formula? Shortcut. We all like a shortcut. All right. Now, the formula looks longer. So for some people, they're a little intimidated by the formula. Now, we're going to work the same problem, so the same data, and see if we get the same answer with this new formula. Now, here's the first thing I want you to notice. What did you have to find over there that you don't have to find over here? The mean. So, X bar is not in this formula. Now, do you understand over here, if you had found the mean, what if you'd made a mistake when you found the mean? You see that the game's over at the beginning? Because now you're using the wrong number? Well, see, this solves that problem because I have to find the mean. Now, here's something else I want you to notice. What's different about this parenthesis right here and this parenthesis right here? Because they look almost the same to me. Where the 2 is. So the 2 is inside this parenthesis and what? Outside that one. That changes everything. Because you got to do order of operations. Don't you have to do what's inside of a parenthesis first? So do you understand on this one, am I going to square the data first or add the data first? What am I going to do here? I'm going to square the data first and then do what? Add those answers up. So I square a bunch of times and then add. Now, right here, you told me I did parentheses first. What's the only thing in the parentheses? You see, it just says add the data. So here, I'm going to add first and do what? Square second. So see, the order flips on you. So you've got to make sure you notice little things about formulas, like where that exponent is changes it, or changes everything. All right. Now, what does N stand for the whole semester? What does it stand for in your formula for mean? N is your number of pieces of what? Of data. Okay, what's your N? If this is your data, what's my N? 5. So it's supposed to N, we'll put 5. Now, notice what happens right here. Do I square first or add first? What do I do first? Square. So do you understand I've got to square that 5 and square that 8 and square that 6 and square that 5 and square that 9. Is everybody with me? All right, what happens when you square the 5s? What are you going to get? Aren't you going to get 25s? When you square 8, what do you get? 64. That's when you square 30, you get 36 done. So that's when you square 9, you get what?
81.
81. Now add those up. What'd y'all get when you added them up? 231. Does everybody agree? So that's what you got when you squared that number, squared that one, squared that one, squared that one, squared that, and then added them up. So that's what this one means. All right, it says minus. Now, what do I do right here? Do I square first or add first? I just add my data. So now I'm going to add 5, 8, 6, 5, and 9. Right, what'd y'all get when you did that? What'd you get when you added them up?
33.
33. But now what have I still got to do to that 33? I'm still going to have to do what in a second? Still going to have to square it in a second. Now, remind me, what'd you tell me n was? You know piece of data. How many pieces of data up there? 5. I mean, if n is 5 up here, it's not going to change in the middle of the problem. Now, also notice this. This n's not multiplied by both parentheses. It's only multiplied by the first parenthesis. All right, so I've got to say 5 times 231. So go do that. Did y'all get 1,155? All right. What's 33 squared? Find that out for me. What'd y'all get?
1,089.
1,089. Now, what do I do first here? Do I do parentheses first? So I've got to subtract here. So what's 5 minus 1? 4. Okay. Now, what is that 5 times that 4 going to give me? And that give me what now? 20. Now, subtract these two numbers on the top. 1,155 minus 1,089. Did y'all get 66? Okay, I'm kind of out of room, so I'm going to go to the side. What's 66 divided by 20?
300.
Okay. Should start looking familiar, shouldn't it? And what's the square root of that about 1 point what? Isn't that exactly what we got last time? I can work it either way.
You're explaining what the 1.8 means.
Yes. All right. What it's saying is this. On this table over here, let me back this up so they can see it here. This is the average. Every piece of data differs from that average. So this number is about 1.6 away. This number down here is about 2.4 away. This number is about 0.6 away. The average differences is kind of what standard deviation is. That's about how far your data varies from the middle on average. Is that a little better? Okay. Now, I don't care which way you work it. Now, what would you know on a test if this second number right here came out to be bigger than this first number under this root? What if that second number is bigger than that first number? What's that going to make this difference? Negative. Is that okay? No, that means that you've made a mistake. So you're not going to be taking the square root of a negative number. Is everybody with me? So there's some checks here. So that's one way of doing it. That's a second way of doing it. A third way of doing it is this machine will do it for you. Okay? So let's talk about how to do it with the machine. Okay? Now, let's put calculator. So everybody pull the calculators out. Because I've got to teach you to do some things with your calculators. First thing you're going to have to do is you have to put the data in a list. Well, how do you do that? How do you put your data in a list? Everybody got their machines out. There's a button that says stat on it. Guess what stat stands for?
Standard.
Statistics. Is everybody with me? All right, on my machine, it's like the third row, right there. Everybody see their stat key? All right, push the stat key. At the top, it should say edit, calc, and test. Is that where everybody says? I need to be on edit. Now, it's probably already highlighted. If it's not, that's what these arrows in a circle are for. You can move that cursor around by using the up, the down, the right, and the left arrow. When it's on edit, hit enter. Now, here's what comes up on my machine when I do that. Like L1, L2, L3, everybody ready with me? Now, I don't care where you put your data, but you're gonna have to remember where you put it because in a minute you got to tell the calculator where it is. I tend to put mine in L1, list 1. All right. So put each value in the list, each piece of data. So what do I mean? What's one of them? Let me ask you this. Depending on if it's your machine or somebody else's machine, you may need to clear the data. If there's already data in there, you're gonna have to clear it out, okay? So if you need to clear the data, I'll put this first then. Clear data if necessary. Well, how do I do that? All right, you're gonna put that cursor on L1 if you're doing list 1. So I'm gonna have to, my first number is highlighted. So I'm gonna have to move my up arrow to my L1 is highlighted. Everybody with me? Now, what I'm gonna do is I'm gonna hit clear. Clear is right under your circular buttons. Do you see where it says clear? Now, when you do that, it doesn't clear it yet. It's afraid you've made a mistake. So what's happening on the bottom of my screen is there's an L1 and an equal and the cursor's blinking at me. It's saying, are you sure? So to say, yes, I am, hit enter. And the list gets wiped out. All right? So if you've got to clear the data, you've got to highlight the list name at the top. You've got to hit the clear button, and then you've got to hit enter. I'll look in a second. All right, now what I want you to do is enter each piece of data. And you have to hit enter after you do it. So I'm going to type in 5 and hit enter. And then 8 and hit enter, and so forth. Is everybody with me? So enter all your numbers in your list.
I was trying to clear from here instead of.
Yeah, you have to go up to there. Now hit clear. All right, now when you hit clear, it clears it out. In other words, you have to highlight that, hit clear, and then hit enter. Okay. You're welcome. Okay? Now, I'm going to teach you some other things to do in a second. So has everybody got their numbers in their list? Now let me show you something. I've got my numbers in my list, and at the bottom it says L1, and in parentheses it's got a 6 and equals. Is that what's happening? That's telling me it's waiting for me to enter my 6th number, which means I must have already entered how many? 5. That's a way to double check to make sure I didn't skip it. Everybody with me? Now what am I going to do? I'm going to go back to my stat key again. So now hit stat again. So I'm going to go back to my stat key. But this time I'm going to go over to calc. So I'm going to right arrow over till I see calc. Calc stands for calculate. So is everybody over there on calc? Under it, it says 1-VAR stats, 2-VAR stats, med, desk, med. Everybody with me? I got a whole list. I want the first one. I want one variable statistics. And when it's highlighted there, hit enter. So on your machine now on the screen, it should say 1-VAR stats and the cursor's blinking at you. It's waiting for you to tell it where the data is. So now you've got to tell which list. Now mine was in L1. So above my 1 key, it says L1 in a different color, like mine's yellow. Well, see, I've got a yellow button. So if I want L1, I have to hit second 1 and L1 pops up. So your second button, that color should correspond to that color of your L1. If you put them in list 2, you tell it to go to L2. Is everybody with me? So you've got to remember which list. So now my machine, it says 1 variable stats L1. Now hit enter. And a whole bunch of stuff comes up on your screen. Everybody with me? So here's what's on my screen right now. 1-var stats, and then it says x bar 6.6, sum of x 33, sum of x squared 231, sx 1.816590212, sigma x 1.624. It keeps going. And it's got n equals 5. Is everybody with me? What does x bar stand for?
Average.
This calculator will also do the mean for you. When you add up the data, you got 33. Now, did we do that a minute ago on the shortcut formula? And we got 33. It will also add up the squared data. We did that a minute ago on the shortcut formula and got 231. Now, this is where you got to be careful. I don't like this notation from Texas Instruments, but I didn't program the machine. The symbol for standard deviation is just S or sigma, not SX or what? Sigma X. So on a test, do not give me TI's notation, give me math notation. They're just telling you that's the standard deviation for that data. Is everybody with me? Now, we're not doing sigma, we're doing S. If you give me sigma, I'm going to count it wrong. We're using a sample, so there's your answer. And sure enough, rounded to the nearest tenth, it says 1.8. The difference in these formulas is, remember over here we divided by n minus 1? To get sigma, they do divide by n. It's got something to do with something called degree of freedom that we're going to talk about later in the semester. That's why the values come out to be different. And we're supposed to be dividing by n minus 1, so you better grab this one, not what? Not that one. Now, the only problem with doing it on the calculator is partial credit's not going to happen very good. Is everybody with me? So you got to be real careful. You don't want to do all that and then grab the wrong number. Okay? So the calculator will do all the work for you, but you have to know how to get it off the calculator. All right, is everybody tracking with me so far? Now, let me show you one more thing real quick about what the calculator will do. Let me go back up here to enter your data in a list. All right. Remind me where I go to enter data in a list. What do I go to? I go to what? Stat, and then I go to what? Edit. Go back to stat and edit. Is your list still there? It is, isn't it? Is it in order from high to low? Not mine, because I just typed it in that way. Is everybody with me? The calculator will also order a list for you. Now, how will it order the list? Go back to stat. What's under edit? What does it say? Sort what? A. All right, go down to sort A and hit enter. All right, you got it? Is a parenthesis open with a cursor blinking at you? It's asking you what you want it to put in order. Well, my data is in L1, so I've got to tell it to go to L1. Is everybody with me? So I'm going to hit second and 1 and then close my parenthesis. That's above your 9 key. You got it? Now hit enter. What's the calculator just say? Done. What's that mean? I did it. Well, I need to look at it. So remind me, how do I get to a list? I just go to what? Stat and edit, right? Go look at your list now. Is it in order? It is, isn't it? From low to high or high to low? Low to what? High. Okay, go back to stat and go down to sort D. And hit enter. It's waiting on you to tell you the list, right? So second 1 and close my parenthesis. When I hit enter again, it says what? Done. Now go back and look at your list. So stat and edit. Is it in order? But the order is different, isn't it? What's this order? High to low. So what do you think sort A and sort D stand for? What's A and D stand for? Ascending and descending. So sort A puts them in order from low to high, and sort D puts them in order from high down to what? Low. So sometimes when you have to do things like a frequency table, it might be advantageous. Instead of tally marks, what you could do is put the data in your machine and make the data what? Put it in order. That makes them easier to count. Is everybody with me? So the machine will actually order your data for you if you want it to. So when I tell you to do standard deviation on a test, you can use the long formula, the shortcut formula, or the calculator. I'm probably going to start using the calculator, but some people really like that shortcut formula. Now, if you've got a small number of values like 5, the long way is about the same amount of trouble as the shortcut. But if you've got a long list of numbers, this first way I showed you gets really long. So that's when the shortcut formula is really advantageous. It's when your list is longer. The quickest way is always the machines. Everybody with me? But the machine is using the shortcut formula. It's programmed into the machine. Okay? So you got to find standard deviation. Now there's a third way to find a measure of variation. Now remind me, what was my first way? Range. Second way was standard deviation. Your third way is going to be variance. Now, there's not really much work here. Variance is just your standard deviation squared. The symbols are that. S squared or sigma squared. Is everybody with me? So like before, didn't we get our standard deviation to be like 1 8/10? So what am I going to do to that 1 8/10? I'm going to what? Square. I can't type. There's my variance. Now, it's a little bit on because didn't I round this one a little bit? So my little bit of error just got a little bit more. Do you understand it's the number under the root? Now, so if you miss the standard deviation, you're automatically going to miss what? The variance. But I'm not going to double whammy you on a test. So if your standard deviation is wrong, but then you square that number, you get full credit for your variance. You right with me? Because you did it right. Now, it seems a little silly to do both. Does that make sense? But the reason we're doing both is some disciplines do standard deviation, some disciplines do variance. Business seems to really like variance. Science and education seem to really like standard deviation. But do you see if you know one, you automatically know the other? If I know the standard deviation, I can go over to business, I can get the variance. Or if I'm in business and I know the variance, I can easily take the square root and get back to what? Standard deviation. So we got to talk about both because it depends on what discipline you're in as to which one you're going to see more often. So when I give you a list of numbers, you got to be able to find the what? The range, the standard deviation, and the what? The variance. Is everybody okay? Now, there's one more thing I want to show you real quick. Okay. And that is this, on page 111 in your books, this is going to be part of your homework. Remember how you had to do the mean of the table? They're going to show you a formula for the standard deviation of the table. Now, I'm not going to have time to do one, I just want to talk you through it. It's a different formula. This formula is on your formula sheet. Let me put it in parentheses. So that formula is on your formula sheet. So you don't have to memorize the formula, but you do have to use the formula. Now, what does F stand for in this formula, do you think? Frequency. So that's not a problem. Now, what did I tell you X is stood for in every formula?
Data.
Your data. But remember back a minute ago at the beginning of class, you don't have your data on a frequency table, right? So on a frequency table, what are you going to have to use for your data? The midpoint. And again, what's different about this one and this one is where that 2 is. Do you see that this 2 is outside that whole bracket? But this 2 is not outside of that bracket. So I've got to be real careful what I do. So does everybody understand? Oh, wait a minute. See, I wasn't paying attention. I copied it down wrong. Like with the table, that 2 is right there and that 2 is out there. So I've got to be real careful. So what I normally do is I copy a formula from my formula sheet to my paper. And then I go back and I start double checking to make sure that my brackets and my parentheses and my exponents are all in the right place. Everybody okay? Now look at the difference. Do you understand? I'm going to square every midpoint. So again, I would square this 12 and get 144. And what am I going to do with that squared number? I'm going to multiply it by its what? Frequency. So I'm going to square that and say 144 times 11 and write it down. I'm going to say, square 17 and say that answer times 2 and write it down. I'm going to square this 22 and say that answer times 5 and write it down. Is everybody with me? Then what am I going to do with all those answers? I'm going to add them up. Now look at the difference over here. I don't say F times X squared, I just say F times what? X. So I'm not going to say 144 times 11, I'm simply going to say 12 times what? 11. And 17 times 2. And 22 times 5. Now what am I going to do with those answers? I'm going to do what? Add them up. And then I'm going to square that answer. Is everybody with me? So here I do a bunch of square. You I don't square till the ends. Everybody with me? Now, what does N stand for? Your number of pieces of what? Data. Is N 3? No, it's not number of classes, it's number of pieces of data. How many numbers must have been in my original list?
18.
How do you know 18?
Because you add up all the
Because you add up all the frequencies. There were 11 numbers just here. Is everybody with me? So that N is not number of classes, it's number of pieces of data. So you're going to have to add those frequencies up to know how many must have been in your list. So that's the formula that you're going to use to find the standard deviation of the table. Okay? Where's your work going to be? On move. All right, I will see y'all next time. Let me know if you have any questions.